Alright, students, now comes another interesting question concerning two limits. So you have been told that the limit of k squared into k minus 4x over x squared, k squared minus 16x squared as x approaching to k is the same as the right side limit. So you are asked to find the value of k for this to happen to be true. So how can we do this? Very simple, students. What we need to do is we have to evaluate the limit of these two, one after the other, and then we equate the two and try to look for what? K from this output, okay? So here goes the solution. What we need to do is we have to find the limit of the left expression. So the limit of k squared into k minus 4x divided by k squared minus 16x squared at x approaching to k is the same as this one. Students, everything is the same, but what has been done here is the denominator is factored. K squared minus 16x squared is the same as k minus 4x into k plus 4x, because 16 is the 4 squared, right? So we can have this. The reason why I'm doing this is because I am unable to use direct substitution, because if I put in k in place of x, 0 over 0 is going to come, okay? So to avoid that problem, I can write in this way. Basically, students, you can also use derivative in order to find, okay, this limit output. You can use L'Hopital's rule, okay? But let me show you how using simplification is done. So we are having now this expression because k minus 4x can be cancelled by k minus 4x. Then you are left with the limit of k squared divided by k plus 4x as x approaching to k. Now, dear students, I can directly put what students? K in place of x, okay? In place of x, I can put that. And then I can have this, the limit of k squared divided by x approaching to k, k plus, actually, anyway, we have that, but it's not good to write in this way. But you see, instead of having now this limb, I better avoid this limb here, okay? I can have k squared over k plus 4k alone. Actually, that's written here. It is limit of k squared over 5k. So as x approaching 2k, it's going to be k over 5, okay? It's going to be k over 5. So I'm having now this to be k over 5. You see, k over 5. I could have written, okay, I could have omitted these, these two steps and say directly k over 5. Actually, no problem. Anyway, we have this k over 5, students. What about for the right one? The limit of negative 1 plus x to the power of 4 over minus 1 plus x cubed as x approaching to 1. Again, here we are unable to use direct substitution, but we are free to use derivative in L'Hopital's rule, okay? But let's factor it. My x to the power of 4 minus 1 can be factored as x squared minus 1, x squared plus 1, as you see. And the denominator, you see, x cubed minus 1 can also be factored like this, because we know that 1 is a 0 of this one, so x minus 1 is a factor, so we can divide x cubed minus 1 by x minus 1. We can obtain that to be x squared plus x plus 1 using long division, right? This comes to be your quotient. And the remainder is going to be 0. Now we need to further what, students? Factor this x squared minus 1. So we know that the x squared minus 1 is factored as x minus 1 x plus 1. So everything comes as it is. But now comes the case where we can cancel the expression that hinders us not to substitute. So x minus 1 can now be cancelled by x minus 1. You are left with x plus 1 times x squared plus 1 over x squared plus x plus 1. Now, am I able to use substitution? Can I put 1 in place of x? Yes, I can. Yes, I can. You see? So when you put 1 there, you will get 4 over 3. Now, students, there you do have k over 5. Here, you're having 4 over 3. So, for this to happen, necessarily, k over 5 must be the same as 4 over 3, students. You see? So, from this, one can simply know what k is going to be. Just take 5 to the right, you will obtain this to be 20 over 3. So it is when k is 20 over 3 that this comes to be true. Now, dear students, in the comment part of this YouTube, I'm now asking you to write the value of k for this particular for this particular case. Even if the left expression is identical to the one I did, the right one is something different, students. The right one is something different, so I would like to let you calculate the value of k and write your answer in the comment part, please. Now coming to the next one, we are having question number 8. This says evaluate the limit of 8 minus 8 radical y plus 2y minus radical y plus 2 as y approaching to 4. Students, am I able to use direct substitution? What happens if I use direct substitution? If I use direct substitution, student, this comes to be 0 over 0, which actually is a determinate type of limit, right? Can we apply derivative or L'Hopital's rule for this? We can, guys. We can find the value of this using L'Hopital's rule or application of derivative, right? But now I'm going to show you how this can be obtained using simplification approach. So this is the idea. The limit of 8 minus 8 radical y plus 2y minus radical y plus 2 as we approach to 4. Now let's factor the numerator. You see, when you factor the numerator, students, 8 minus 8 radical y plus 2y, you'll obtain this to be 4 minus 2 radical y into 2 minus radical y, students. So from this, these 2 minus radical y can be cancelled by 2 minus radical y. Having minus radical y plus 2, by the way, is the same as 2 minus radical y. Now I obtained, you see, two similar expressions that can be cancelled here, so I can cancel these two. Now I'm left with this 4 minus 2 radical y as we approach into 4. Now students, am I able to use substitution here? Yes, I can. Nothing hinders me, nothing restricts me here, okay? So I can directly substitute, you see, 4 in place of y and have 0 here, okay? Because radical 4 makes 2 and 2 times 2, 4, 4 minus 4 makes 0. Yeah, you do, students. Now I just have given you this sort of question. You are asked to evaluate this limit. So as usual, you need to write your answer in the comment section, please. Now here something's changed. Yeah, everything's changed as we're approaching to 1. The previous case was we're approaching to 4. So please, I strongly recommend you to do this and write this in the comment part, okay? Thank you. Now proceeding to the next one, you see we have important notes that we need to know, okay? These are important things that you need to know whenever limits of functions limit of function is concerned. So the first one is the limit of sine x over x as x approaches 0 is 1, students. If you observe the graph of f of x equals sine x over x, around 0 we do have a hole, but everything gets closer to number 1. See, whenever we get closer to number 0, the y-axis, the function approaches to number 1. That's why we are having this, okay? The limit of sine x over x as x approaching to 0 is 1. Here, the limit of 1 plus 1 over x, the power of x as x goes to infinity is e. You student must know it, okay? So when you simplify the expression inside the bracket, you do have this, x plus 1 over x, the power of x. And again, we can also use the limit of 1 plus x, the power of 1 over x as x approaching 0. Basically, dear students, these two are identical. This concept is identical to this one. The thing here is, as x, let you use y to be 1 over x if you want. If you use y to be 1 over x, x is 1 over y. Look, 1 over y. So if y is 1 over x, and as x goes to infinity, y approaches to 0, students. So x approaching to 0 can also be. So the two are identical. That's why we're having e. So you students must know all this, you see, because very fundamental. The limit of sine kx over mx as x approaching to 0 can be k over m, students. Actually, this can be verified by using this one, the one I told you before. And the limit of, you see, 1 plus c over x, the power of x, is e the power of c. This basically is proved directly from this one, but you know that whenever you do have this kind of expression, but this one is different, and if this is c, okay, you can have e the power of c, students, e the power of c. For example, the limit of 1 plus 2 over x, the power of x is e squared. If c comes 3, it will be e the power of 3. This is actually directly, okay, directly taken from this concept, okay? And not only that, you look here too, the limit of 1 plus 1 over x, the power of cx as x going to infinity is e the power of 3. E the power of c. This is a very simple concept because you are having this 1 plus 1 over x, the power of x, c times. So you are supposed to repeat this one c times. So if this comes to be e, so you are going to have e the power of e, how many times? 3 times. E times e times e times e. It goes up to c times. So we can write that as e the power of, students, e the power of c. So students must know this all because there are certain limit questions involving this kind. So you better know them as much as possible. Thank you.